Hello students, hello everyone. Welcome to Senior College Mathematics. Topic of discussion is surds or radical, as you may call it. Okay? If you are in senior college, you are preparing for WAEC, NECO, GC, NAPTEB, JAMB, or any other external exams into high school, this topic, this lesson is for you. You are in the right place. PetakusEducation community. Lesson 5, division of surds and conjugate of binomial surds, part 2. So lesson 5 is continuation of lesson 4. Before the details for updates, follow PetakusEduCom via YouTube at Petakus Simplified Maths. To do that, subscribe to this channel, like and share this video to your friends, your classmates, your colleagues. Facebook at fb.me/PetakusEduCom, Instagram at PetakusEC, Telegram t.me/PetakusEduCom, WhatsApp through this mobile telephone number. In all of these platforms, you get updated from time to time about what is happening at PetakusEducation community, where you have access to quality, unlimited, and simplified mathematics teachings in series. Okay, more example. Already I've explained the concept of binomial surd and its conjugate in lesson 4. And we solved one example in that lesson, so we'll continue with the solution, or by taking more examples in this lesson. Example 38. You have 13 plus root 5 all over 5 root 8 minus 4 root 6. To simplify this kind of problem in short form, you have to rationalize the denominator, and in doing that, you find its conjugate, and the conjugate is simply changed in signs. This is the denominator. Its conjugate is 5 root 8 plus 4 root 6. You get that? Okay. Use it to multiply both the numerator and denominator. So this is the given problem itself. The conjugate of the denominator, which is this, is used to multiply both numerator and denominator. Next thing is to expand. I've explained that before. First term times second term, first term times first term and second term. When you are through with that, second term times first term and second term. Same thing happens to both numerator and denominator. Okay, so you take 13 now. 13 times 5 root 8, that is 65 root 8. You go back to the same 13 times 4 root 6. You have 52 root 6. Then you take the second term, root 5, times 5 root 8, that is 5 root 40. You take the second term, root 5, times 4 root 6, that is 4 root 30. See that? To the denominator, the first term, 5 root 8 times 5 root 8. That is 25 times 8. 5 times 5, 25. Root 8 times root 8 is root 64. And root 64 is 8. So you must note that. Okay? The second term times 4 root 6. 5 times 4, that is 20. Okay? The second term. Okay, so let's continue with the multiplication. This second term, okay, I should do the first term. First term times second term here. 5 times 4 is 20. Root 8 times root 6, that is root 48. So you are done with the first term against the two terms in the second part. Then you take the second term, 4 root 6, that is minus 4 root 6 times 5 root 8. Minus 4 times 5 is minus 20. Root 6 times root 8 is root 48. Then the last term there times the second term in the second part. Minus 4 times 4, that is minus 16. Root 6 times root 6 is 6. You get that? Okay. So let's try and simplify. The numerator, we can express 840 in basic form. Okay? So root 8 can be expressed as 4 times 2. Root 6 is already in simplest form. You can express root 40 as 4 times 10. Root 30 has no other factor that is a perfect square. For the denominator, plus 20 root 48 minus 20 root 48. These two terms turns to 0. That you are saying plus 1 minus 1. You have 1 and you are owing 1. By the time you pay, nothing is left. So the two terms disappear. Alright? 25 times 8 is 150 minus 16 times 6. You have 96. Okay. Root 4 is 2. So you have 2 root 2 from that place. This term remains the same. Root 4 is 2. That is 2 root 10. And this term remains the same. 150 minus 96 is 54. Okay. If you check all the terms in the numerator, instead of multiply them, we can see that 2 is common. So if you factor out 2, and use that 2 to divide this term, well, this is one term now. This is one term. That 2 you factor out, remove this 2. So you are left with 65 root 2. This is another term. Divide 52 by the 2 you factor out, you have 26 root 6. This is another term. The 2 you factor out divides that term. These 2 disappear. You have 5 root 10. The 2 you factor out divides here. You have 2 root 30. So that 2 can divide 54 and you are left with 27. If you check the numerator, it's already in simplest form and all the surds are different. And that means you cannot add. You cannot add. So this is the simplest form that your answer can be. And you stop there. Are you following? Okay. Example 39. You have 2 root 3 plus 3 root 2 over 3 root 2 minus 2 root 3. Our emphasis is on the denominator. So you must use it conjugate to multiply both numerator and denominator in order to rationalize the denominator. So this is the denominator. Its conjugate is this, minus changes to plus. Okay, so this is the given problem. You multiply it by the conjugate, both numerator and denominator. So you multiply first term 2 root 3 multiplies first term and second term. So you have 6 root 6 plus 4 times 3. Now let's check that. 2 times 2 is 4. Root 3 times root 3. Root 3 times root 3 is 3. Hence you have 4 times 3. The second term, 3 root 2 multiplies the first term and second term. That is these two terms now. Okay, so 3 root 2 times 3 root 2, that is 9 times 2, because 3 times, okay, so let's continue. That is correct. So we're now using the second term now to multiply the first term. So 3 root 2 times 3 root 2. 3 times 3 first is 9. Root 2 times root 2 is root 4, and that is 2. Then the second term times the second term, that is 2 root 3 times 2. 2 root 3 root 2 times 2 root 3. I'm saying now 3 root 2 times 2 root 3. 3 times 2 is 6. Root 2 times root 3 is root 6. For the denominator, first term times first term and second term, you have this result if you check it properly. Then second term times first and second term, you have these two results if you check it properly. So you must take note of the signs. Okay, so you have 6 root 6, that's the first term, the numerator. 4 times 3 is 12. 9 times 2 is 18. Then 6 root 6, the last term, the numerator. The denominator plus 6 root 6 cancel or takes care of minus 6 root 6. Both terms becomes both the plus and minus. Okay, you are left with 9 times 2, that is 18, minus 4 times 3, that is 12. So we can add the numerator 6 root 2, 6 root 6 plus 6 root 6. Remember, similar sort can be added. So that gives 12 root 6 plus 12 plus 18 is 30. 18 minus 12 is 6. You can factor out 6 from the numerator to cancel the 6 in the denominator. If you factor out 6, it's already out. So if you divide through 12 root 6 plus 30 by 6, you have 2 root 6 plus 5 all over 6. 6 remove 6, you are left with 2 root 6 plus 5. 2 root 6 plus 5. Are you following? Okay. Example 40. Before rationalize, remember you can rationalize when you have a single expression. So this is like solving fraction. So the first thing you must do here is to simplify first by finding the LCM. If after that your answer there is still rational number in the denominator, then you think of rationalizing. So this like simplifying fraction where we start by obtaining the LCM, and the LCM of root 7 minus root 3 and root 7 plus root 3 is the product of the two denominators. So you write down the LCM, and you know the rule. You divide the LCM by the first denominator. You are left with root 7 plus root 3 that will multiply 5. Okay, so if you divide the LCM by the first denominator, you are left with root 7 plus root 3 that will multiply 5. That is the result you have here. Okay, then you divide the same LCM by the second denominator. You are left with root 7 minus root 3 that will multiply the second numerator in this form. Then you expand both numerator and denominator. 5 times root 7, you have 5 root 7. 5 times plus root 3, you have plus 5 root 3. If 1 opens a bracket, you have it in this form. Since 1 is positive, it has no effect in the bracket. Then the denominator, root 7 times root 7, that is 7. Root 7 times plus root 3, that is plus root 21. The second term, minus root 3 times root 7 minus root 21. Minus times plus is minus. Root 3 times root 3, that is 3. That is 3. Okay, we can add common terms or similar sort in the numerator. So 5 root 7 plus root 7, that is 6 root 7. Then 5 root 3 minus root 3, that is plus 4 root 3. In the denominator, plus root 21 minus root 21 is 0. You are left with 7 minus 3, and that is 4. That is 4. That is 4. At this stage, looking at the coefficients of the rational number root 7 and root 3, that is 6 and 4, you can factor out 2 because 2 is common to both coefficients. You factor out 2 and you divide 6 root 7 by 2, you have 3 root 7. Divide 4 root 3 by 2, you have 2 root 3. Reduce 2 and 4, 2 is left in the denominator. If you wish to continue, you can split it down. That is, the two terms in the numerator, they share the denominator equally in this form, Then these 2 can divide these 2. 3 and 2 can non-divide. So you have 3 over 2 root 7 plus root 3 as the final answer. If you wish to stop at this level, you are equally correct. Okay? Example 41. This is just like example 40, and because it is subtraction of fractions, the first thing is to find the LCM of the denominators. 3 plus root 5, 3 minus root 5. Because both terms are different, the LCM is their product. So you take the LCM first. If you divide the LCM by the first denominator, you are left with 3 minus root 5 multiplied by 1, and you have 3 minus root 5. You divide the same LCM by the second denominator, you are left with 3 plus root 5 that will multiply 1, and you have it in this form. This term is in bracket because 1, it has 2 terms and is coming after a minus sign. Remember, minus sign always has effect on 2 or more terms, so you must put it in bracket to avoid mistake. Here can be written as minus 1. So if you open the bracket with minus 1, you have minus 3 minus root 5, because minus times plus now is minus. Then if you multiply the denominator, 3 times 3 is 9. 3 times minus root 5, that is minus root 5. Then you take the second term, root 5 times 3, that is 3 root 5, plus times minus is minus, root 5 times 5 is 5. For the numerator, 3 minus 3 is 0. You are left with minus root 5 in this form. The denominator, minus 3 root 5 plus 3 root 5 is 0. You are left with 9 minus 5. So minus root 5 minus root 5 that you are saying minus 1 is minus 2. So minus root 5 minus root 5 is minus 2 root 5 all over 4. 9 minus 5 is 4. If you reduce 2 and 4, that is 2 is common, you are left with minus 5 over 2. Since 2 is a rational number, you don't need to rationalize again. If you go further and multiply both numerator and denominator by 2, you're already going the wrong way. You only do that when you have an irrational number in the denominator. Assuming that 2 now is root 2, then we go further and rationalize. Since 2 is rational, that is the final answer we have from simplifying that problem. Okay? All right. End of lesson 5. Thanks for watching and learning with PetakusEduCom community. Don't forget, watch out for more from the voice of Petakus. The voice you are hearing is the voice of Petakus. For questions and inquiries, use the comment section. For the complete package of this topic, lesson 1 to 6 for offline usage, you can contact the voice of Petakus via this WhatsApp number or through the email address, and at a very little token, you get the complete package delivered to you. Lastly, if you are not safe, your life will be in crisis. To avoid that, you need to give your life to the one that can save you, and that is the Lord Jesus Christ. If you are saved already, I tell you, big congratulations. Live righteously and be prepared, because on the last day, some will be taken and some will be left. Take good care of yourself. Stay out of trouble. Stay well. Study your books. Do the needful at all times. Flee every appearance of evil. Don't defraud others for money. Use your hands and your brain to work, and the Lord will surely bless you. Goodbye for now.